Welcome everybody to another Weiler Wednesday webinar. My name is Nate Schmid. I'm the Director of Marketing at Weiler Abrasives. Today I'm joined again by Rick Hopkins, our Technical Training Manager, and Elliot Shepard, our Associate Product Manager. Today's webinar is the second of a two-part series on resin fiber discs. Today's webinar will talk about maximizing resin fiber disc performance and solving application challenges. If you missed the first webinar, which was last month in February, you can go to our website under the resources section and watch the recording after this webinar. So if you missed that one, don't worry about what you missed. You can go and grab that at any time at WeilerAbrasives.com. Just a reminder, we have muted all lines to prevent any background noise. And as we go through the webinar today, if you've got any questions, we'll use the Q&A function within Zoom. So post your questions at any time and we'll cover those questions at the end of the webinar. And then lastly, we will have a giveaway today, as we've done in previous webinars. So pay good attention. And if you get that question right, we will draw a winner at the end and announce that winner to the audience before we go into the Q&A. So without further ado, I'm going to hand it off to Rick and Elliot. Take it away, guys.
Okay, thanks, Nate, and welcome everybody. Thanks again for joining us again. And Elliot, you know, like last week, we talked about the ways that you can maximize the performance specifically of a resin fiber disc. But one of the things that some people had asked is, you know, why is a resin fiber disc necessarily better or different from a grinding wheel, a flap disc, right? So what are the differences? So we figured we'd take a couple of minutes and talk through the features and benefits and why a user would get some benefit out of one versus the other.
Right. So, you know, basically to start off, we're going to speak to some of our flap disc. We'll talk about some of the bonded abrasives, and then we'll compare them to the resin fiber disc. So when I was a fabricator years ago, we would use resin fiber disc mainly because they had the aggressiveness of a belt abrasive. And then they had that backing pad to give it a little bit more versatility, as we spoke about in our previous webinar.
Yeah, no, absolutely, right. And one of the things that a lot of people don't know is that before resin fiber or before flap discs were really brought to the U.S. by the Weilers, and we uncaged the original Tiger disc, a fabricator would use a hard grinding wheel to get material out of the way, right? Get that weld out of the way. And then they'd have to switch to a resin fiber disc, but resin fiber discs were really thought of as finishing tools, right? Polishing and finishing tools. And so there's two things, right? There's one, the fact that there's a lot of switches and changeovers, and then again, you know, some of the real ability and the focused aggression that you can get out of a coated abrasive was a little bit lost.
Right, exactly.
So what makes a big difference between any coated abrasive and a bonded abrasive is the fact that a bonded abrasive, we have no control over how those cutting grains, right? We always talk about abrasive grains as knives, cutters. And with a bonded abrasive, any bonded abrasive, we have no control over how those grains are facing the workpiece, how they're actually attacking the material. Where with a coated abrasive, we can actually orientate the grains so that all of those sharp edges are actually focused and pointed directly at that work surface. And so you can really get the maximum aggression.
Right.
So
when we're talking about the flap disc and kind of you know, if we take the idea of the bonded abrasive and we take the idea of the resin fiber disc, we're able to orient the grains, but we also have a little bit of a cushion to allow for more compression on the flap disc. And we have the phenolic back to add some rigidity, but compared to the RFD and really compared to the bonded, there's more compression in that. So we lose a little bit of aggressiveness.
Right, absolutely, right? Because what you lose is that firm backing that's actually physically driving the abrasive into the work surface, which is with a resin fiber disc, because you're using it with that firm backing pad, you get all the benefits of both worlds, right? So that's where, right, and you couldn't have said it better. You get that belt-like aggression with the versatility and the reach of a right angle grinder.
Right, exactly.
So just to give everybody a little bit of a feel for the difference in performance on three similar welds, right? Elliot, tell us what you're gonna walk us through and we figured we'd just give everybody a little bit of a visual to show the difference in the three different products.
Yeah, exactly. So over here, I have 3 separate welds. What I'm going to do is I'm going to do one single slow pass with our Tiger Zerk. I'm going to do a slow pass with our Tiger Paw flap disc, and then I'm going to use our Tiger Zerk RFD. So what we're looking for here is, for one, we're going to listen to some of the sound that comes out of the bonded abrasive compared to the flap disc and the RFD. We want to look at removal rate and really look how deep that cut goes in. We'll see that RFD and that belt aggression is going to really drive into there comparably to our bonded abrasive and our flap disc. Okay, so I'm going to get loaded up here. I'll start with the bonded abrasive.
Okay. All right, so again, right, we're going to use, Elliot's going to start off with our Tiger Zerk, right? So this is a good high-performance zirconia alumina hard 1/4-inch grinding wheel that he's going to run that first weld bead, one slow pass. One of the things that we'll point out, right, and just take the time to mention, and one of the things that I always encourage, particularly with newer operators, or when you're trying a new abrasive that you're not really familiar with, is to enter that initial grinding stroke on a pull, right? And the main reason for that is, particularly with a hard grinding wheel, depending on your grinding angle, how much pressure you're using in your approach, and the softness of the material that you're grinding, you can really get an initial bite right out of the box where that grinder wants to kind of, what I describe as submarine or dive into the workpiece and can potentially cause damage. So one of the things that I encourage is to always take that initial stroke with a pull to enter the workpiece, and that gives you the opportunity to really feel what that abrasive is going to do. So just wanted to make sure we pointed that out. All right, so let's go back to talking, Elliot, about the benefits of a hard wheel, right? Particularly when you're grinding on jagged, sharp corners, right? Really hot, right? When you're grinding hot, these kinds of things can really be damaging to a coated abrasive, cause the coated abrasive to break down. So a hard grinding wheel will give you some benefit there.
Right.
But one of the things that's immediately noticeable to me is the vibration, right?
Yeah, immediately you can hear the chatter. I can feel the chatter through my arms, my elbows, and if you're doing that for 8 hours a day, that's going to be a rough day for you. So realistically, when you're using that bonded abrasive, you have that chatter because it's such a hard wheel, right? So when we look at the scratch pattern, you can see where it's digging in, where that chatter is actually coming from.
Yeah, and so if you want to start, right, one of the things that, obviously that's difficult, we don't have anything to compare it to yet, but as you grab the flap disc, right, and we'll jump into what a flap disc will do on that same weld. And so again, right, listen, don't just look and watch what he's doing, but actually listen for the sound, right, the variation in the control, the difference that the grinder's doing. And I think you're going to run the flap disc on the outside weld there to really show, again, right, that same single controlled pass down the entire length of that weld, and we'll look for how much of that weld is removed, and then we'll also look at that finish pattern. Right. So now again, right, one of the things, Elliot, and I'm really interested for you to kind of share the actual physical feel, right, which is something that I certainly can't experience. But the one thing that was clearly noticeable is the difference in the sound that grinder was making, and the lack of that vibration and that chatter across the workpiece.
Right. So it's audibly quieter, definitely a lot softer feel, a lot smoother when you're grinding, and a lot easier to control. So that's a big thing too. As a new fabricator, you get tossed a bonded abrasive. That takes some learning to get used to it. But if you get tossed a flap disc, you have a little bit more cushion, and it's a little bit softer, and it doesn't pull as hard. So for somebody new to start off with a flap disc or an RFD, it makes it a little bit easier for that learning curve.
Yeah. Now, and again, right, what you compromise in hardness of the wheel and that initial aggression, you somewhat make up for, and you can see that flap disc did a really good job, removed a lot of weld in that single pass.
Right.
But now let's take a look at what a resin fiber disc is going to do, and where you can really start to combine the best of both worlds by getting that hard backing that's really driving and forcing those cutters into the workpiece. But the benefit of having those focused points, right? Those sharp knife edges that are really what's pointed to and attacking on the workpiece. And so what a dramatic difference, right? And again, I'll ask you to talk and comment on the actual feel of it. But again, in that same single pull, you're almost completely through that weld and into starting to really remove it in small cases, actually almost through that mill scale, right? In certain parts. But talk to the benefit, and talk to ultimately the benefit that you would experience as a fabricator when you're trying to get that job done.
Right. So for me, feeling that, it was a little not as soft and as cushiony as your flap disc, because you don't have that cushion in between the flaps. But with the RFD, I didn't have any chatter like I had with the bonded abrasive, but I also removed more material over a shorter period of time. So that's huge when it comes to time effective projects when you're doing work in the shop. So obviously time is money. But the best part about it is that I'm able to get almost a complete finish step while removing that amount of material. So I'm basically almost combining these two into one pass.
Absolutely, right? Yeah. So now, right, Lena, let's talk about it in the scope of a real fabrication job, right? Obviously, you would have removed the mill scale prior to the actual weld, right? So we put the cart a little bit before the horse, just in the scope of really giving you the opportunity to see the amount of material that's removed in a single pass, one versus the other. But now let's talk about mill scale, which is a challenge for any fabricator.
Right. So, I mean, hot rolled steel, you're going to have that mill scale. And it's a huge pain when you go to fabricate. So using a product that gets rid of it efficiently, it's a big deal. We'll show you. So the amount of passes it takes for a bonded abrasive to get through, we'll look at the flap disc, and then we'll look at the RFD. But one thing we want to notice is scratch pattern, amount of time, and then if we need to go back and reprocess, do we need to go to another step, or can we do it all in one step, right? So again, time is money. The more time you spend finishing and changing things up, changing wheels out, the more money, more cost you add into the products.
That's perfect. And in the interest of time, we don't necessarily need to take the time to talk about it. Let's have you run the hard wheel, and then at least go into the flap disc, right? So that everybody has an opportunity to really kind of visually and hear a difference in the two products. So again, this is that Tiger Zerk 1/4-inch grinding wheel. Highly clean, very efficient, right? Cut through it very well, right? Again, right? We did hear that chatter, right? Let's show them the flap disc, and then we'll talk about the difference in the finish. Okay, great. And so now this is where you can really see a difference, and you could hear a difference as well, obviously. But one of the interesting things, right, that flap disc, and this is where that cushioning actually becomes a little bit of a detriment, right? Because as you noticed, it took you 2 or 3 strokes before you even really start to see any spark. That's a product of that abrasive initially just kind of wanting to slide across that hard shell.
Right. and it felt a little greasy. So you feel it starting to kick and grab over certain areas as that mill scale is getting removed. You know, the mill scale doesn't want to go anywhere. So it's tough to get it to remove when you have something that's as cushioned as a flat disc.
Yeah, absolutely. So now again, right, let's show the performance and the benefit to a resin fiber disc in that same mill scale application. All right, and so again, right, significantly, right, you had much more of that same aggression of that grinding wheel without the vibration, and more importantly, significantly, and I'm not going to touch it directly, but a much better scratch pattern with both those coated abrasives as you would normally expect, right? So again, right, that goes back to your comment earlier about secondary processes and what you need to do, the things that you need to do when you start with a hard grinding wheel.
Right, right. And just to point out, so I did 15 passes here. Probably could have done less, but to get things smooth, you want to be able to do as many or the passes that it takes to do the work. The flat disc, I did 20 passes, and this resin fiber disc, I did 12. So there's a big difference. And what I want to add is I did 15 passes here, but I'm going to have to go back and clean this up again. I could go straight to weld with this because we're flat and smooth.
Yeah, well, and again, right, one other thing that I just wanted to point out, right, is with both the grinding wheel and the flap disc, it's a much more focused, fixed, narrower contact patch, right? And so you can see the grooves in those passes where the benefit, again, of that resin fiber disc and the fact that that backing pad really spreads out that contact patch.
Right.
As you look at that final finish, again, you're doing less evening of that work surface because you have much less gouging, undercutting, and that's damage to the actual physical surface.
Right. And my first full pass here from the resin fiber disc, I felt I was at removing at least 3/4 of an inch to 1/2 inch of mill scale just on that first pull. When, you know, our flap disc barely removed any on that first pull. You know, our bonded abrasive did a great job removing it, but that's a secondary process to clean it back up.
Yeah, so again, right, we're not talking in any way and saying that resin fiber discs are the end all and be all, right, or any one of these abrasives. Right. But there are benefits and there are also compromises with any product that you choose. And resin fiber discs, for the one main downside to a resin fiber disc over the other two products, right, that flap disc and the grinding wheel, is the fact that you are only talking about a single layer of abrasive, right? So overall, you are going to go through more resin fiber discs. You're going to use more resin fiber discs in a given space. But again, in the concept of productivity and time being money, depending on that application, right, that may be providing the value when you consider the possibility of eliminating secondary operations and cleanup.
Right. And then one small thing to note too is we've been in many facilities where they're using bonded or flap discs. And a lot of the times they're not using them to their full life in the first place. So, you know, we keep that in mind too as we look at these products.
Absolutely. So let's talk for a second about why I would choose a specific grain or a performance tier in my resin fiber disc, right? So we'll start with aluminum oxide. You know, clearly the most economical.
Right.
And aluminum oxide grains are great, sharp grains that do a great job initially. The challenge is that an abrasive grain or an aluminum oxide grain will gradually just consistently dull right out of the box from the minute that you start using it.
Right.
Right. So in a resin fiber disc, you're going to feel that depletion. In a grinding wheel or a flap disc, they're designed so that as those grains start to dull, the product wears away and exposes sharp, fresh grain. You don't have that in a resin fiber disc, so you are going to start to feel that.
Right. And one thing to note too, I mean, with the aluminum oxide grains, they work very well on softer materials, cast irons, something a little bit more ductile. You know, because those grains are dulling, they don't need to be as hard on those softer materials.
Absolutely, and they're great finishing grains, right? Partially because of the fact that they are a dulling grain, a more blocky grain, they are going to create a better scratch pattern, lower roughness averages, right, and get you to a desired finish more quickly.
Yeah,
right?
we used to keep our 36 grit RFDs and save them for finishing applications because they would dull down and we'd be able to get almost an 80 or a 120 finish off of a 36 grit that's been used up.
Awesome, right? So now let's talk about the opposite end of the spectrum, because the one thing that I'll see, and one of the conversations that I'll have, right, many times an aluminum oxide resin fiber disc is chosen, or an aluminum oxide abrasive in general is chosen because it also happens to be the lowest cost, right? And what sometimes people lose sight of is the fact that the lowest possible price does not always mean that it is the lowest cost of use, right? So many times, so we're going to jump up to a ceramic disc, right? Which again is the complete opposite end of the spectrum. And ceramic grains are designed to fracture so that they can maintain their sharpness. They literally self-sharpen as you're using, so that they maintain that sharpness for a much longer period of time.
Right, and we've seen it multiple times at end users where we get called in where a customer's saying, hey, we're using a ceramic disc. What do you got? This thing isn't working great for us. And we go in and we notice that, you know, for one, they might have an underpowered tool. They might be using extension cords that are causing a bottleneck in power. What those grains really need is they need that RPM and that torque to be able to fracture those grains and self-sharpen. They need help doing that. So having the right tools and the right power is a huge part of the ceramic grain itself.
100%, right? But ceramic grains and their ability to maintain their edge, just like any cutting tool, right? It's not so much any abrasive is sharp right out of the box.
Right.
It's about how well it can actually stay sharp throughout the course of its use. And ceramic grains, certainly under the appropriate conditions and with the necessary accommodations, will absolutely do that. So now you're looking at your high nickel alloys, your armored steels, tool steels, Inconels, titaniums, mixed, you know, the materials that are going to be much harder to grind and are really going to take a toll on specifically an aluminum oxide grain and cause that grain to dull at a much faster rate.
Right, and the ceramic grain specifically with our Tiger Ceramic RFD is paired with the top coat. So the top coat's extremely important for these, because what happens is on those stainless steels and harder materials, because they're harder, they generate more heat. So that top coat is actually used to keep those temperatures down. And then it will actually reduce some of the discoloration, heat discoloration, something that we would have to go back to later and reprocess to get it back down to that base material.
Absolutely. Another great point, right? And you know, Chad can zoom in and show us the difference between, right, a comparable grinding line with a grinding wheel, a typical grinding wheel on a thinner gauge material versus that top coated resin fiber disc, and the significant difference in the same amount of time, in heat discoloration, right? So that cooling aid, right? Think of spraying PAM on a fry pan, right? It's going to do several things. We'll talk about that in a little bit in the scope of aluminum and soft materials. But one of the main benefits is the ability to keep grinding temperatures cooler and minimize, ultimately eliminate that heat discoloration that can also require a secondary operation and or a secondary product to come in and actually clean up and finish the part.
Exactly.
So we'll move down to Zerk, and zirconium grains are great, probably the most popular, right? That mid-tier, right? Harder and sharper than an aluminum oxide grain and maintain that edge. And they also kind of fall in that mid-performance and mid-price range. And we offer a Tiger Zerk resin fiber disc, which also incorporates a little bit of ceramic grain in here. So now again, right, for any of those versatile general purpose grinding on mild or even higher carbon steels, maybe particularly if you're running with a lower power tool or a mid power tool, or have some challenges there, whether it be pneumatics with air and volume, Tiger Ceramic is going to provide you that ceramic cut rate and performance, ultimate performance on that wider range of tools and powers. Wolverine Zerk is really a great product in that it provides a lot of the benefit of the zirconia alumina grains that we just talked about. But by incorporating aluminum oxide into the mix, now you do have a product that can give you some of that better finish quality and finish pattern right at the end, at the tail end, without having to change or switch the disc to an aluminum oxide.
Right, and you know, I'm a little biased because my custom fabrication background, whenever I would use generally any type of resin fiber disc, it was AO or Zerk. And that was mainly because we wanted to blend into parent material. So when we were doing that, we wanted to do it efficiently. It was a small shop. We were 4 people. So, you know, it wasn't in the cards to pay for something like a ceramic or something along those lines. So we made do with what we had. But it was a really great grain and did exactly what we needed it to do.
Absolutely right. And so in the interest of time,
yep,
and to talk through just the last rep, we certainly want to talk about aluminum oxide grains and the benefits, particularly in softer materials like aluminum. But one of the biggest challenges with working with those materials is loading, right? The fact that that material will want to stick to the sides of the grains and build up. And so where we talked about a top coat or a grinding aid to help keep temperatures down, our Tiger aluminum resin fiber disc has a different non-loading formulation that's designed to really prevent that material from even sticking, right? And allow that material to clear as the disc is rotating, to provide that same level of finish that you'd get with a conventional resin fiber disc on a steel part, on an aluminum part, on a copper, brass, bronze, non-ferrous material, or soft alum.
Right, and you know, before top coat for aluminum specific products, a lot of people were using that the aluminum oxide grain, but they were putting waxes, they were putting some sort of lubricant on it. That gets on the floor, it gets all over you, and not to mention it's a secondary process to clean with some sort of acetone, paint thinner, you know, something that's, you know, not great for your skin, not great for the material. So using something that's like an aluminum specific top coat product like the aluminum RFD, you know, you're eliminating secondary cleaning processes, and then you're really keeping everything clean enough so you could go straight to weld after grinding with the product.
And you're going directly from the box to the grinding operation, directly from the grind operation to the finish, as you said, right?
Right.
You don't have to, with any of those other methods that you described, you actually have to physically treat the disc. You have to physically treat the workpiece.
Right.
With Tiger aluminum, you go directly from the box to grind, and then directly from grind to finish.
Exactly.
So that's, you know, and again, right, you have one more demo that you wanted to give everybody. So let's talk about, and I think you're talking about conformability here.
Yeah, so we're going to talk a little bit about conformability. So I threw some weld beads on our pipe here. What I want to do is I want to show what the contact patch is between a flat disc, a bonded abrasive, and then an RFD with a specific flexible backer. So I have 3 separate backers set up. I have a hard, a regular, and a flexible. So the flexible is going to give us a little bit of a larger contact patch. And that's huge when you're doing a non-conformable surface because you want to be able to remove the weld without removing parent material on the sides. So I'm going to go through all 3 and then we'll compare them and we'll have a look and have a listen of what we feel and what we think.
Yeah, so again, right, and, you know, the big benefit here, without sharing too much too early, is the fact that, right, we talked about the benefit of that rigidity of the backing pad and that wide contact patch. But we wanted to bring it all back around to what we talked about last week, is considering the application and choosing the right backing pad, right? And so as you referenced a more flexible backing pad, which is an option. So again, you have that versatility with the accessory in order to drive the abrasive, but it's about thinking through what your application is and what you're most after. Excellent. Yeah, no, I mean, I think if you want to just jump right to the next one. It's great, Elliot. You can take the boy out of the fab shop, but you can't take the fab shop out of the boy. Right, and it's interesting, right? Because you can see, right, as you started to get through that weld, and you could see where the disc was starting to come in contact with the with that mill scale. You could see where it started to slide a little bit more, right? You were losing that aggression until you started to work through that mill scale and crack through to the bare base metal. And now again, what the big difference to this backing pad is this is our flexible backing pad versus the harder, the medium or the harder backing pad that we would use on a flat surface, right? A flat, more consistent surface, right? But again, to show the fact that you can get a high level of conformability while maintaining that wide contact patch with the appropriate backing pad. Very consistent in maintaining that curve and that arc, right? And again, right, the biggest thing that I noticed from back here, the easy part of the job, was that never flinched when the abrasive came in contact with that mill scale, right? Never lost any of that cut rate, never had any of that sliding. That the disc just kept going, and you're able to do in less time the same or more work.
Right. So, you know, what I felt realistically is, as I'm going through that weld and as I'm burning through with the RFD, the minute I start to hit that parent material, it kicks that mill scale away. You don't feel any difference. When I was running the flap disc, because of that compression, I had to press a little bit harder for it to get in there. And once I started to hit the mill scale, that was causing it to skip a little bit and making it not remove as much material. The issues I had with the bonded abrasive, and if I feel it this way, I have a deeper cut. So the issue with that is I could potentially cause harm to the parent material and maybe have to re-weld this and refinish it. So, you know, keep that in mind too, as far as the contact patches and what abrasive you're using on a conformable surface.
And no, that's awesome, Elliot. And I, you know, thank you very much for the run through. I think you have a giveaway to offer and a question for everybody before you get into the takeaways.
I do. So what we're going to do is, in the comments, the first person to answer this question is going to get this pretty sweet Weiler Carhartt bag. So I know we spoke about top coat, but the first person to answer this question, and if you can put an application in here of why we would use a top coated product, the first one is going to get this bag, and we'll make sure we send it out to you.
That's great. Yeah. So, and I guess while we're giving some people time to answer, if you want to take them through and wrap things up.
Yeah, I'm super fogged up right now. I'm sorry, I can't see anything.
Yeah, no, absolutely. Right. So again, right, we're not saying that resin fiber discs should necessarily replace every abrasive in every application and all the time, but resin fiber discs absolutely provide that belt-like aggression.
Right.
And that with some conformability options and the versatility of your right angle grinder.
Exactly. And, you know, real next point, you want to be able to tailor your backing pad to what you're doing. If you're doing something like a conformable surface, you know, pressure vessels, anything that has a curve to it, a finer or a more flexible backing pad is going to work better. Then you can go to your regular or your hard backing pad, depending if you're doing something flat, right? So keep that in mind. The next thing is be able to select the grain for your specific application. I know we walked through a couple different grains here, from ceramic to zirconia alumina to aluminum oxide. And we really dove into which ones were specific for which applications. So keep that in mind as you're moving through and looking at products.
And don't forget or lose sight of the fact, right? We understand that these products cost money and right, there's an expense involved, but sometimes, right, you overlook the cost of use. Right. when you're choosing an abrasive that's cheaper, right? And so, you know, again, right, the big thing here is don't necessarily confuse the fact that upfront disc for disc price may be actually ultimately costing you money when you consider the amount of time that it's taking you to get the job done, the amount of secondary and third operation.
Exactly. Next real point, you know, you want to make sure that you have the right power to the tool. using a thin extension cord, something you would plug in with your Christmas lights, that's going to choke your tool and you're not going to get the right power to it to be able to do the job. It affects ceramic grains a large amount, so you want to make sure that you're doing that the right way. Make sure you give your tool the best chance of performing in the best and most efficient way. And then the last thing, top coats, right? So
yeah, and I guess we'll let Nate jump back in and announce the winner, and we'll let the winner tell us what the benefits of top coat.
Exactly, that's even better.
Yeah, thanks, guys. So our winner is Georgia Stewart. She provided at least one of the correct reasons, which she provided, which was provides less friction, was her answer. But if you guys want to expand upon that regarding top coats, and then we can get into some resources and next steps.
Of course. Yeah, so friction is directly correlated to heat, right, Rick? So the more friction, the more heat you're going to put into the product, and then you're going to add discoloration. So having that top coat is going to be able to add or take away some of that heat to be able to minimize discoloration. And then in the case with the aluminum, Tiger aluminum RFD, it adds that lubricant, right? So it's the PAM on the frying pan, like you said before. It's able to move those aluminum specks and pieces of material out of the way and out of the peaks and valleys, so it can be more efficient and keep cutting as it's moving forward.
All right, good deal. Well, thank you, Rick. Thank you, Elliot. Just a couple of resources that we want to share with our audience. We do have a lot of resources regarding resin fiber discs, and as you saw, there's a lot to resin fiber discs. We just came out with a new resin fiber disc selection guide, so we'll send that in a follow-up email to everybody that joined the call today. And it talks about a lot of the things that Rick and Elliot talked about and how you select the right resin fiber disc for the job. We'll also include the resin fiber disc checklist that we went over on the previous webinar, and then also a case study with our Tiger ceramic resin fiber disc. Rick and Elliot talked about the benefits of being able to grind faster and get the job done quicker. And in this case study at a pressure vessel manufacturer, they ultimately saved $62,000 a year by using our Tiger ceramic resin fiber discs. As always, if you've got questions, you need help with your abrasives applications in your facility, we're here to help you. You can go to our website at weileраbrasives.com and fill out a contact form. You can reach out to your local Weiler district sales manager, or of course you can give us a call on our 800 number, and we will be sure to help you with your abrasives applications and make sure you're getting the most out of the product and ultimately getting your jobs done faster, safer, and better. So I want to thank everybody for joining us today. And before we get into any Q&A, just a reminder, if you do have a question, you can submit that in the Q&A function within Zoom, and we will answer the questions that have come in. So let me just switch over to the questions here. All right, let's see. We've got a few questions that have come in. One question, Rick and Elliot, that came in is, what's the most aggressive grit that Weiler offers in their resin fiber discs?
So it's a great question.
So for our resin fiber disc, 24 grit is going to be the most aggressive. Pairing that with the right grain is going to give you the real amount of aggressive. Growing up, you have people that like that 36 grit and they stick with 36 because of the scratch pattern and what they want to use. So it depends, but really our line is the 24 grit that's going to be the most aggressive.
All right, thank you. Question about resin fiber discs and stainless steel. Is there a particular resin fiber disc that you recommend for stainless steel applications?
Yeah, I mean, I can take this one. So specifically top coated Tiger ceramic is great for stainless steel because it keeps those grinding temperatures down. And it's able to cut through that material with the ceramic grain and keep cutting as you're moving through the life of the disc.
Well, I think just one thing to point out, right? One of the important things that's potentially on your mind as far as stainless steel is contaminant free. The need for no iron, sulfur, and chlorine, and so all of our performance resin fiber discs are contaminant free, so suitable for use on stainless steel. Now, right to your point, the top coat will certainly be beneficial in minimizing heat discoloration and that sort of thing, but by the same token, Tiger Zerk, with its combination of Zerk and ceramic grains, are also going to perform extremely well, cut very cool, and do a good job on stainless steel.
All right, great, thank you. And one more question right now. Again, if you've got any final questions, feel free to submit them in the Q&A, and we'll get to them. But the last one we have right now, how long does a resin fiber disc last compared to the other options that you showed today, the flap disc and the hard wheel?
So that's a tough question, right? I mean, that's really going to be dependent on the operator. Your angle, your pressures. I grind it very lightly because I came from a finishing background. So the bogging down and pressing really hard is going to make the life of the flap or the resin fiber disc a lot shorter comparably if you were to grind the way I grind, and very light. You might know as far as percentages that might be somewhat close.
Well, I don't, right? And your answer is absolutely correct, right? I mean, there are so many factors that are involved, right? Regarding the pressure, the angle of approach, and so on and so forth. I mean, certainly, again, right? One of the main differentiators in a resin fiber disc is you really only have that single abrasive coat, right? So once the one downside to a resin fiber disc is once that grain depletes, the disc depletes. Where with both a flap disc or a hard grinding wheel, the wheel will gradually wear away, continue to expose sharper grains, fresh grains, and maximize the use. Now, there are a lot of things that you can do to prolong the life, right? One of the first ones is to not grind so steep with a resin fiber disc, and to actually take advantage of your cutting surfaces on the work surface, right? By spreading that out, you minimize the focused heat that's being transferred back into there and can extend the life. Our backing pads have cooling fins on them to help promote circulation from the backside, to help cool from the backside of the disc, which has shown to prolong life of a resin fiber disc. But certainly, right, I would be lying to you to say that you're going to get the same life out of a resin fiber disc as you would out of a flap disc or a hard grinding.
Right, and the same aspect too is you could bear down on an 80 grit and have it last a very short amount of time, or be really light with the 36 grit and it could last an extended period of time. So you bring up a phenomenal point there, and one last thing to consider is the fact that because of the focused aggression on the backside, if you're using a 40 grit flap disc in particular, you may find that you actually get higher aggression and work done faster with a 60 grit resin fiber disc, right? So, because again, it's all about the focused cutters onto the work surface. So again, right, another benefit, right, while you may ultimately, like theoretically, if you're counting strictly grind time, not get the same life. When you consider parts produced and the ability to get the job done more quickly, there are many applications where you can find yourself reducing that time by switching to a resin fiber disc versus some other coated abrasives. Right.
So that was the long-winded, which I typically have, answer to a very pointed question, but hopefully that was helpful.
That was great. Thank you, Rick. Thank you, Elliot. That's the last question that we have. I know I learned a lot today. I hope the audience learned a lot. And again, if you've got any additional questions, don't hesitate to reach out to us, and we'll help you best we can maximize your abrasives applications and selections. So,
and if you think that using resin fiber discs is exciting, wait till you read about resin fiber discs.
That's right. All right. Thank you, everybody, for joining today. Have a great afternoon, and we'll catch you next time on another Weiler Wednesday webinar.
Thanks, everybody.